All right, so I'm just going to do a couple of quick practice questions on how to balance chemical equations given some written information about some type of reaction. Let's get started. So in the first one, what we're told is that we have solid iron 3 oxide and carbon monoxide reacting together to produce iron metal and carbon dioxide gas. Now, what I'm going to do first is write up the formula for each of these substances, both for the reactants and the products. Then we can start focusing on writing chemical equations. So the first one here, iron, Fe in our periodic table. It's iron 3, so it has a charge of 3+. And we have oxide over here, which is just elemental oxygen. Its charge, we can do that off the periodic table, is 2- because it's in column 16, which means that it has 6 valence electrons. Now, what we can see is that the charges of these two ions are not balanced. You can either use the cross method or you can count charges. Either way, you should be able to figure out that the formula is Fe2O3. So you can either do the cross method to figure that out, or you could also increase the number of oxygens and increase the number of ions so that there's an overall charge of +6 and -6 to balance out the charges there. But that's our first one. We also have carbon monoxide, so C and mono means 1, so C for carbon, 1 oxygen. We also have iron metal, which will just be Fe, and we have carbon dioxide gas, so C for carbon, di meaning 2, so 2 oxygens, CO2. So there are all of our elements. We now just need to put them into a chemical equation and balance them. So I'm going to be writing Fe2O3, so iron oxide, and that's reacting with carbon monoxide. Before I do that, though, I should put the states in. So solid iron oxide. It's reacting with carbon monoxide gas, it says. So CO gas. And that's producing, so arrow to show our products, iron metal. Metals are solids in almost every circumstance. So Fe solid, and carbon dioxide gas is being produced as well. So CO2, and then in brackets, gas. Now, what we need to do next is balance our equation. And what I can see is that there are not even numbers of iron, even numbers of oxygen, or even numbers of carbon at all. So what we're going to do is try to balance out the equation as best as we can to try and figure out how all of those atoms react together and in what ratios they react together in. So this one looks to be quite tricky. It might take a little bit of trial and error to figure this one out. So I'm just going to talk through it as I'm working it out. I haven't tried to do this by myself already, so maybe just see what I'm doing and the thought processes that I'm taking to get to my answer. Now, what I can see is that there are 4 oxygens on this side and only 2 over here. So the first thing that I'm going to do, just put a little 2 at the top to say, well, what if I had 2 oxygens on this side and see how the oxygens balance out then. So I'd have 4 and 4 here. But what I can see now is that the number of carbons are currently unbalanced. So I'm going to put a little 2 here. That's 5 oxygens on this side versus 4 on this side. So even though I've balanced my carbons, it hasn't completely worked out yet. Now what I could do instead is maybe increase this to 3 and 3. So I keep my carbons balanced. I then have 1, 2, 3, 4, 5, 6 oxygens, and 3 times 2, 6 oxygens on this side, 3 carbons. The only thing now that is unbalanced, and I probably should have put an E there, my mistake, is balancing out my iron. So I can put a 2 over here, and because it's all sort of working out and all a little bit messy, I'm going to do a full rewrite. So Fe2O3 plus 3 carbon monoxides is going to turn into 2 ions plus 3 carbon dioxides. And there we have it, a fully balanced equation based on what was written up the top here. One more quick example. Ammonia gas reacts with oxygen to produce nitrogen monoxide gas and steam. Now for this one, it takes a little bit more memory or know-how about some of our common compounds. Now, ammonia, there's no real indication of what it's made of or anything like that, but hopefully, eventually, at least, we should know that ammonia is NH3, and it's said that it is a gas. Keep in mind, if you are doing any of these practice questions yourself and you don't know what they are, either look them up or ask someone else if they know what they are. There's no point sitting there going, I'm going to try and figure out what it is if it's clearly not including any of the names of the elements that are present and it's just some kind of common name. Look it up. Don't waste your time. Eventually you'll learn names like this. But ammonia gas, it reacts with oxygen. So oxygen gas in the air is O2. It's a diatomic. It's not just oxygen elemental atom by itself. And that's producing nitrogen monoxide. So one nitrogen, mono or monoxide, one oxygen, and that's a gas as well. And it's also making steam. So again, common name, that is water or H2O. And if it's steam, it means that it's in a gaseous state. So everything that we're working with is a gas. The only thing that we've got to do now is try and balance out our equation. Now, what I can see is that really nothing is balanced. The nitrogens are balanced, the oxygens are as well, but the hydrogens are not balanced. And this is going to take a little bit of work to completely balance out. So what I can see here is that NH3 has 3 hydrogens, H2O has 2 of them. We're not really going to be able to increase one of these and magically fix the situation. We're working with odd and even numbers here. Now, if I know that I have even numbers here, I can only increase my number of hydrogens on this side by even numbers. So there's no point keeping this as a 3. I want this to be even as well. So I'm going to put a 2 out the front here straight away because I know that the number of hydrogens on my reactant side are going to have to be even at some point for this to balance out. So here I have 2 nitrogens and 6 hydrogens. What I need to do on the other side is make sure that I have 6 hydrogens there as well. So I'm going to put a 3 out the front. Now looking at what I've got going on, my hydrogens are balanced, 6 and 6. Now let's look at some of the other elements. So I've got 2 nitrogens here and only 1 on this side. So I may as well just put a 2 out the front and see what happens. At this point, I now have 2 nitrogens, 6 oxygens still. I've got 2 oxygens here and 1, 2, 3, 4, 5 oxygens on the other side. Now this becomes a little bit of a worry because when I start to look at balancing this, again, I encounter a little bit of a problem. I have 1, 2, 3, 4, 5 oxygens, and I can only change my number of oxygens on this side by even numbers, which means no matter what I do to the oxygen over here, I'm never going to be able to make this balance out properly. I'm never going to be able to hit 5. So what that means is that I'm probably going to end up having to have over here an even number of oxygens. And this might seem a little bit weird at first, but I'm going to increase this all the way up to 6. And the reason that I'm doing that is because this means here I'm going to have 12 hydrogens, which means I can also double the amount of ammonia that I've got over here to make 12 hydrogens. So I'm continuing to balance out the hydrogen here, and I'm just doing that by doubling the amount of ammonia and water that I've got. And what that's going to mean is once I balance everything out in a minute, is I should hopefully end up with an even amount of oxygen here, which is very easy to balance out at the end. But anyway, I've got 4 nitrogens versus 2. So I'm going to put 4 nitrogen monoxides. At this point, I have 4 nitrogens on both sides. I have 12 hydrogens on both sides. Here I've only got 2 oxygens still. On this side I have 4 plus 6 is 10 oxygen. So all I would need to do is put a 5 out the front and all of my elements are balanced. Let's write that out a little bit more formally. NH3 plus 5 O2 turns into 4 nitrogen monoxides plus 6 waters as a gas. And there we go, our balanced equation. Thank you very much, everyone. Hopefully we've got a little bit of a better idea of how to start writing up chemical formula. What we're going to be doing is every time we sort of do a new chemical reaction in class, whether they're practical or not, we're probably going to have the opportunity to write down some of those chemical formula. So we're going to be continuing to practice that anyway as we go. But next time we're going to start looking at types of chemical reactions. Now there's a big list of them that we need to cover. So I'm splitting them up into 3 parts over the next week's lesson. But until then, have a good one.